So we're going to take a look at factoring a difference of squares this time around. And first I'm going to just start out by showing you an example. So this will be example 1, and the instructions are to factor. And what we're going to factor is x squared minus 36. So some people may remember how to do this already, but in this case, I want to show you where it comes from. So here, a lot of people will just look at this and go, okay, that is x plus 6 times x minus 6. That's because they already know the secret. They already know what's going on. So it's not by magic. It's this to get from here to here. It's not by magic. It's just remembering the difference of squares pattern. And the difference of squares pattern is if you have something squared minus something else squared, then that is going to equal the square root of this, the square root of this, times the square root of that again, and again, except for you alternate signs in here. One's plus, one's minus. This is what's known as the difference of squares pattern. Let's see if we can get it a little bit darker there. So this is called the difference of squares pattern. Now, the reason why it works, let's see that real quick. Why it works. If we were to take x plus 6 and x minus 6 and multiply, we could either FOIL or do the box. I'm going to FOIL in this case. So x times x, that's x squared. X times negative 6 is negative 6x. X times, 6 times x is positive 6x. And then 6 times negative 6 is negative 36. So what happens is those cancel out. They cancel out to 0. So we get x squared minus 36. This happens every time. This pattern always happens. So if we get something, I guess that's what I'm trying to say here. If you have this side, then, I guess I should have put in, then we get this. So we can start here. If you notice something squared, and there's a minus sign in between. Must have a minus in between. If it doesn't have a minus in between this thing here that I just showed you, it doesn't happen. So if you have something squared, and a minus in between, then you can factor it out as a difference of squares. And that's just by a pattern, because if you FOIL this out, you would get this, and the middle terms would cancel out. So for the very, very simple problems, we'll have something like what we just had, where, let's say example 2. Say we have, I guess we'll take all the easy ones. Actually, yeah, we'll take another easy one. Factor, an easy one, and then a little bit more tricky one. So x squared minus 16. Now normally you would think, okay, try and factor out a GCF. There aren't 3 terms, so I can't factor the trinomial using x factor or the x method or super x. There's nothing I could do here, so you think. But I know that I can square root x squared, and that gives me just x. And I know I can square root 16, and that gives me 4. If I got a decimal here, then I wouldn't be able to use the difference of squares pattern. I wouldn't be able to just split it up this way. So since I can write those as two perfect squares, I mean they're already written as perfect squares, since I can figure out what the square roots are exactly, then I can just write two sets of parentheses, the square root of this one in the fronts, and then the square root of this one in the back. I'm not square rooting a negative, I'm just square rooting this. And then alternate the signs here, plus, minus. If you were to FOIL this out, you would get x squared minus 16. That's the pattern that we're going to be looking at. We're definitely going to get some more difficult examples like this one. We're supposed to factor, and let's see here. What did I have? I had it. I just had it. Yes, okay. So 81x squared minus 49. I know this is a perfect square and this is a perfect square, so I can square root both, and that gives me 9x. I can square root that, and that gives me 7. So this difference of squares pattern still works, even though this is like a little bit more complicated. 81x squared, I can square root x squared, it gives me x. I can square root 81, it gives me 9. So even though it's a little bit more complicated, I can still write down my two parentheses, 9x, 9x, 7, 7, plus, minus. And that is factored. It's not always this easy, but I guess the first thing that I'm trying to do is always factor out a GCF. Let me pause it. So always try to factor out a GCF. And then the second thing that I'm doing, if I can't do that, is check to see if I have perfect squares, meaning square root each term. Actually, I do have to check to see that this is a minus in between, so maybe I'll write that. So always try to factor out a GCF. The next thing is to remember to check to make sure that there's a minus in between. So that's the second thing. So you must have a minus in between your two terms. And then check for square roots. So if you square root each term, do you get a perfect match? Does it go in, or is this a perfect square? Meaning when I square root, I get a whole number or a whole term. So check for perfect squares. Those are the three things that I'm doing. If all three of these things, well, I guess this part, we'll just make it smaller numbers. If this is true and this is true, if 2 and 3 are true, then I can just jump straight away to my perfect square pattern there. So just separating that. So make sure that you're checking for the minus sign in between and you're seeing that they're perfect squares. Let's look at another example. So on this one, again, we're trying to factor. And that first thing that I wanted to try and check was always factor out a GCF if you can. So that's what I'm going to try and do here. Because 48 is not a perfect square, 49 is, but let's see. I can't divide by any x's, but I can divide by 3, because 8, the trick is if you add these digits together and it's divisible by 3, then the original number is divisible by 3. So 8, 9, 10, 11, 12, that means these are both divisible by 3. Whatever you divide by goes on the outside of the parentheses. And what do we get here? So what is that? 1, that's 18, 6 times 3 is 18. And then x to the 4th, and then minus 1. Remember, this cancels out to a 1 there. Then the next thing I'm doing is I'm gonna not pay attention to that 3 for a little while, and I'll check the rest of my steps. Check for a minus in between, good, and check for perfect squares, meaning can I take the square root of 16? Well, yes I can. That would be square root of 16. That's just 4. Square root of x squared. Some people might get confused with that, but x to the fourth. Square root of x to the fourth. Well, just recall that when you multiply variables, you add their exponents if they have the same base. So x squared times x squared is the same thing as x to the fourth, because we would have added those exponents. So this is actually the same thing. Well, I have something squared. X squared squared. That's the same thing as x to the fourth. I just squared it. It's just like I had 2 times 2, that's 2 squared, or 3 times 3, that would be 3 squared. And if I square root both sides, then I would get, well, the square cancels out with the square root. I'm left with the inside, x squared. So that means the square root of x to the fourth must be x squared. So the square root of x to the fourth, I want to say, is x squared. You're just cutting that in half. You're cutting the exponent in half pretty much. So the square root here becomes 4x squared. The square root of 1 is just 1. So if I square root this, square root of 1 is just 1. And I still have the minus there. So that changes. And okay, that's actually the third step. Check for squares. So I can indeed write this. Maybe I shouldn't have written this down here, because I'm just checking. I was just checking for perfect squares. And I could get perfect squares. So my factor pattern would be the square root of this, which was 4x squared, and 4x squared, square root of that, just 1, 1, alternate the signs, there we go, and then not forget the 3, don't forget to bring down the 3, but here's the tricky part, almost couldn't see that there, here's the tricky part, you should check again, don't forget to check again. Because what do we have? We have, look at this. We have a minus sign in between. So check to see that there's a minus sign in between. There is one. Not on this one. We can't do anything with this. But there is a minus sign in between here. And then we have, well, we can square root this and square root that. What do we get? We get 2x and still just 1. So this can be broken down yet again. So I can have 4x squared plus 1. And then this gets broken down into 2 more parentheses. And what do we get? We get 2x, 2x, right? Whatever that square root was. 1, 1, and alternate the signs. Plus and minus. Now I can't take the square root of 2 evenly, so I'm good there. I can take the square root of 1, but if I can't do it to that, then there's no point in continuing on. And then this is my complete answer. I can't do anything with that. There's no common factor. It's not a trinomial. I can't use super x, so that is it for that. And I think that's pretty much all you can do. Just be aware that when you square root a higher exponent, you're really just cutting it in half. And then don't forget to keep checking. And that's the end of that. Maybe you can do the notes, or do the assignment now, hopefully.